Hello everyone, I'm Marvian and today we are going to solve the LeetCode challenge. The challenge number 123 called the best time to buy and sell stock part 3. And for this particular challenge, we are given an array of prices where the prices of the certain index or the certain element is the price of a given stock on the certain day, and find the maximum profit we can achieve. We may complete at most 2 transactions in a sequence, and we might not engage in multiple transactions simultaneously, like for example we must sell the stock before we can buy again. And for this example number 1 right here, we have the input prices of the array, which is 335, 003, 1 and 4, and the output is 6 is because the first example right here we have the pair of 3 with 5, which is the profit of 2, and we have another profit of 3, and finally we have another profit of 3. Since 2 right here is the first transaction and this part is the second transaction that is considered a profit, and this part is the third transaction that is considered a profit, then we cannot simply put 3 of them into 1. We need to eliminate the least value from the queue of the profits, so we only take this one and this one, which is both are 6 profit in total. And for this explanation right here, we have the to buy on the day 4, which is price 0, and sell on the day 6, which is price 3, and we have the profit of 3, and then buy on day 7, which is on the price 1, and then sell on day 8, which is the final day, with as the price of 4, and we got the 3 as the profit, so the total profit is 6. And as you notice something, we may want to buy the stock on the day 4 right here, which is 0, and then sell the stock on the last day, which is has the profit of 4, but then it is already covered, then we cannot engage in another transaction because it is already covered the whole on the one sequence, which is on the one coverage right here. Then we cannot buy the same thing, which is 1 4, either 1 4 or 3 4 or even 0 and 3, is because it's already covered before. And to take note that we may not engage in multiple transactions simultaneously, we must sell the stock before we can buy again. And on the example number 2 right here, we have the prices of 1 to 5, and we have the output of 4 instead of 1 right here, and then 1 right here, and 1 right here, and 1 right here. It is not 2 but 4. It's because we may engage either 1 or 2 transactions in a sequence of the prices array right here. Then since 4 is the highest value, the highest profit that we can get, so we can just cover the whole transaction from the day 1 onto the final day. So we got the maximum possible profit that we can achieve. And for the sample right here, we buy on the day 1 like I explained earlier, and sell on the final day, which is price of 5. We have the profit 4. And do take note that we cannot buy on day 1, buy on day 2, and then sell them later, as we are engaging in multiple transactions at the same time. We must sell before buying again, which explained right here. We buy on the day 1 and then buy on another day, which is 2 right here on the price 2, because 1 already covered the entire prices range of the day, and then we cover this part. It is not possible, and we can just cover this part like this one on the example 1, like this, and then like this, which is on the separate days of the transactions. And for the example number 3 right here, we have the prices of the 7 6 4 3 and 1. Then we are not going to engage any transaction because it is going downhill from the day 1, so the output is 0. So we already know that we can declare the initial value as 0, and in this case no transaction is done and max profit is 0. And so let's solve this out. For the first one, we need to create a let variable instead of the constant variable. Let variable called the first buy, because we are engaging in either 1 or 2 transaction at max, so we can declare the first one, which is the first buy, and then next one, which is the first sell, and we declare this as 0, and then the next one, which is the second buy, by with the value of 0, initial value of 0, and then the second cell which has the value of 0. Then we can declare this using one pass or the single pass of the prices array iteration. And I forgot to tell you that we are using the TypeScript as our language. If you want to use something else other than TypeScript or JavaScript, then go ahead and encourage you to do so, but the principle or the fundamental still remains the same. Okay, so for the first by right here, we have either engaging in 1 or 2 transactions at max. So hence the second by and second cell variable exists right here. And we can just use a single pass of the for loop, using the for loop of the let I is equals to 0 as long as I is below the prices array dot length and then I plus plus. And for the next one, we need to return the second cell. It's because we are accumulating over from the first by, first cell, and second by and second cell to see which profit that the maximum profit that we can get from the final second cell. And we can just return the second cell variable right here, which initialized as 0. So why is it 0 is because just in case if we have the downhill transactions of the prices right here, of the stock prices, which going from the top to the bottom, then we cannot buy anything. To prevent the negative values, then we can just output the number as 0. Hence the variable initialization value is stayed at 0. So for the next one, we need to declare the first buy. Because we are buying something, then we need to use the math maximum. And using the math maximum, why is because on the first buy we need to declare this as the negative infinity. So it is the minimum value possible of the negative value. And for the Math.max, we can declare either the first buy as the initial value of the minus infinity or negative infinity. Then we can just compare this with the prices of the current iteration. Then we can flip this because hypothetically we are buying something. Then of course we are starting from the 0. Then we are borrowing money somehow, and since buying is considered leading to the negative number, then we can just use the 0 and then minus by the current prices of the current buy price. Then we can just console.log to see how the first buy is going on, first buy on every iteration. And let's run this to see the console.log, the first buy. And we have the value of the 3, and then 5, which on the first iteration we have the value of the 3. Since it is negative infinity, then of course the math.maximum will pick the latter instead of the former, because negative infinity is lower than the minus 3, which is 0, negative 0, subtracted by the current price, the current buying price right here on the day 1. And we stayed at the minus or negative 3 instead of the negative 5, because negative 5 is lower than negative 3. So hence the Math.max method is used right here. So we need to get at least the minimum buying price as low as possible. So the math maximum is used right here, and that way we get the negative 3 as our minimum money that we already spent. And the next one, we might want to use the 0 right here, is because 0 is considered the normalized way to determine the buying options of or tracking that we already spent on the prices right here, on the minimum the least value that we already spent. You might want to use the negative 1 and then using the multiplication operator to multiply the prices, to flip the prices from the positive into the negative, because we are always starting from the 0 or without a profit at all. Then if we happen to run this part, we can see the difference that we have -0 instead of just 0 as it is because if the prices of the fourth iteration is 0, then of course it will be flipped by the -1 right here, because if we the math principle, if we happen to multiply the positive value with the negative value, then it will become negative. If we happen to multiply the negative value with the negative value, then we will get the positive value. So we can just stay at the 0 minus the prices of 1 of the current iteration, is because we are starting from the budget of 0. Then for the next one, as we already get the least buying value, then we can determine the first cell by using the another Math.maximum method again, and we can just determine if the current first cell is the maximum value, either the value of the first cell itself or the first buy added by the current prices of the current iteration. So that way we are adding the first buy, which is only -3 right here, with the current prices. Let's say if we have the 5 right here, then the first buy stays as -3 and the 5 stays right here on the prices I, then it will consider it as +2 or +2. Since the first cell is considered 0, then 2 is going to be picked as the new first cell value variable. Then we will get +2 as our first cell, which from the 3 and 5 right here. So let's declare the console.log using the first one, which is the first buy, and we can just use the template string, the first one, which is on the element of the prices, what prices of the current iteration prices. Oops, it is supposed to be outside of the $sign because we are declaring a variable value inside the template string. The format is $sign with the curly brackets, and then inside the curly brackets is the variable, and we can declare the prices of the current iteration I, and then it's in the comma, and it's just about visualization. You might want to follow this or not, is up to you. And the next one, which is the first buy, is in the dollar and then the curly brackets first buy, and then the next one, which is the first cell. And let's run the code again to see the console.log. And we have the least first buy of the -3, and then we have the value of the first cell of the +2 is because -3 is added by 5 of the current iteration of the third day, and we got the 2 as our profit because on the 3 and 5 right here. And the next one, we get the least value of the least buying value, which is 0 from the first buy variable right here. And we have the variable of the first cell, which stays as +2, is because we are buying on the, is because the 2 right here is from the previous iteration. It is note that it is not possible to buy at 0 and then we sell on the previous day from the day that we already buying the stock. So that is not eligible, and we can just stay as the +2 because from the previous iteration of the day 3. And as we go through the iteration or the traverse, then we will still taking note of the least buying value from the first buy stays at 0 right here, and then another maximum value of the selling on the first cell, which is on the 4 right here. Then we got the maximum profit possible on the first cell of the entire array composition right here. And for the next one, to determine the second buy, we need to declare the second buy as the -infinity, just like on the first buy. And we can declare the second buy to match either the Math.maximum, which one has the maximum value, either the second buy itself or using the first cell subtracted by the prices of the current iteration, just like on the first buy right here. The notable difference is on the second buy, we already got the profit from the first cell right here. Then we can just use utilize the first cell profit and subtract it by the second buy right here of the current iteration. Then to see which one has the higher value, it is the negative infinity on the first initialization of the second buy, or the calculation from the first sell profit subtracted by the current iteration. Then we can just add this using comma and then $sign, and then for second buy, and just run the code again to see the console.log. And we have the second buy as -3 is because it is the least value, and we already changed the value as the +2 is because on the second buy right here we are meeting with the 0, and since the first sell we have the profit of the first sell subtracted by the 0 right here, and we got the value of the 2 because we are not spending anything from the stock price of the fourth iteration, and basically we got a free stock on the day 4. And we can just state the profit as the +2 right here from the calculation of from the first sell, and with the current iteration of the 0 right here because it is free. And as we go through the array, and we still got the maximum value of the second buy as +2. On the final one, we can declare the second sell or the second profit. Then we can just the Math.maximum and compare the second sell, which is itself, with the second buy added by the prices of the current iteration. And that way we are counting the profit just like on the first sell right here. It is the same thing as the first buy added by the prices of the current iteration, and for the second sell it is second buy added by the current prices of the current iteration. And we can just use the equal sign and then pass in the second cell, and we can just run the code again to see the visualization. And we got the accepted answers on the 3 test cases, and we have the profit of the second cell as the +2, which is the total of from the first cell. And to see the profit, and we still got the +2, and then we got the profit of +5 because the first cell right here, it is compared with the second cell or the second buy. I mean on the second cell right here on the previous iteration we got the value of the +2, and we got the value of the +3 on the first buy, and we got the value of the +5 because on the second buy right here of the current iteration we have the value of the +3, and the second buy, which is 2 right here, with added by the 6th day of the stock price, which is +3 right here. Then we got the maximum value of the +5, and as we go through the iteration we got the maximum possible value of the +6. Why we got the +5 right here is because it is going to be tracked from the day 2 and the day 3, and the second possible prices, which either from the 0 with 3 or the 0 with 3 right here, which is 3, and 2 with the 3 we got the value of 5. On the 7th day we still got the 5 because it is priced as 1, and we are not going to do anything about it. And on the final day we got the maximum value of 6 is because either we got this from the 3 with 5 and the 0 with 4, or the 0 with 3, or with the 1 with 4. Then we got the maximum profit of 6. So let's submit our code to see if it all works flawlessly. And we have the output limit exceeded, and we can just remove our console log, and let's submit this again to see if it works. And we have the runtime of the 61 millisecond, which is fairly nice. How about we run this again? It's still 71 millisecond. Okay, so that's about it. I hope you understand my explanation. If you still don't understand, you can ask me in the comment section, or if you have any better solutions regarding this challenge, tell us what you think in the comment section. Thank you for watching the video. I hope you have a great day and I will see you in the next video. Goodbye.